Okay, the clustering algorithm which we did the last time was the k-means and clustering algorithm, and we also covered the k-medioids clustering algorithm, right? And these basically k-means and k-medioid algorithms were based upon the input parameter k, where this k determined the number of clusters to be formed in the data, and the k was always greater than 2 or equal to 2, 3 and 4, 5, 6 and so on and so forth. And once we provided the value of k, that much clusters were produced by the k-means and k-medioids clustering algorithm. In this lecture, we will be doing the density-based clustering algorithm. This density-based clustering algorithm is basically the is implemented on top of a graph, right? In a graph, for example, in a graph we have nodes, and these nodes are connected with each other using edges. The nodes are called vertices as well, and the edges are called arcs as well, right? So in the real world scenario, these nodes may represent, for example, cities, may represent friends network, for example in case of social networking websites like Facebook, LinkedIn. So for example, there is a person, let's say named Z, he has a friend named A and another friend named Y. So since they are friends, they are connected with each other, right? So this is how a graph is represented generally, right? So the density based clustering algorithm is based upon the notion of graphs. Okay, this we already know, so I am skipping this because clustering I already explained this thing in detail. So the graph is a representation, a problem representation scheme which represents the data or a problem as network or graph, you call it. Each node in the graph represent item to be grouped, right? An edge between two nodes represent that these two items are related with each other, right? So in the clustering, we have to find such subgroups or subgraphs in a large graph whose density is more than or equal to a given value. Right? Now, before going further, let me explain to you the notion of density. For example, this is a graph, right? And there is an edge between this, rather let me draw an edge between from every vertex to every other vertex. This node is also called vertex, it's called edge, so I'll be using this term interchangeably. So here I have made a graph where every vertex, for example, this is vertex number 1, this is vertex number 2, this is vertex number 3, and this is vertex number 4. So every vertex is connected with every other vertex directly, right? So this graph, this subgraph has density equal to 1. Later I will be showing you the formula of density, but and the value of density is between 0 and 1, or it can be represented in terms of percentage as well. So the density in terms of percentage is 100%, right? So the clustering is to find such subgraphs whose density is more than or equal to given threshold, right? For example, this is a snapshot of graph of a PPI, protein-protein interaction network, and this shows set of clusters or which have density greater than 0.6, right, greater than 60% density, right. Now for example, if you see this cluster number 1, this is a densely connected cluster, but it's not its density is not 100%, but of course its density is greater than 0.6 or 60%. Now if you see here, this this cluster or this group is 100% connected, so its density is 100%, or you can call it its density to be 1, right. And then before going any further, I recalled a term which is worth sharing here, that is called clique, right, clique. So clique is a graph in which every vertex is connected to every other vertex, right. Now if you see this is a clique where every vertex is connected, but mind it, by when I say every vertex is connected, there is a difference between a connected vertex and a directly connected vertex. For example, consider this graph, right. This is node number 1, this is node number 2, this is node number 3, right. So if I connect 1 with 2 and 2 with 3, now this 1 is connected to 2 and 1 is indirectly connected to 3 as well, because from 2 you can go to 3, like, but if I connect it like this, so it is directly connected, right. So in a clique, every vertex is directly connected to every other vertex in the graph, right. So if you see here, this one is a clique, right. But for example, I make another graph, and if you see this, now this is a graph, but this is not a clique, because every vertex is not directly connected to every other vertex, right. So clique is a graph or a subgraph. In a complete graph, it can be a subgraph as well, where every node or every vertex is connected to every other vertex. For example, obviously this triangle, this is a clique, right. Even these two nodes, although they are not marked as cluster, maybe the algorithm has identified them as noise, but these two nodes can also be regarded as clique, right. Probably, if I'm not wrong, this one is all, I have to count all of the edges, but this seems to be a clique as well, right. So within this complete graph, this subgraph is the clique or clique. Okay, now in density based clustering, a node that is part of cluster should be connected to a reasonable number of edges within the cluster, right. Two nodes belonging to same cluster have more common neighbors than two nodes that do not belong to same cluster. For example, to give you an example, if two persons who are in the same university, so there is a good chance that both of them are going to have many common friends as compared to two persons you pick from different university. For example, okay, let me try to make a person. ये बंदा है, ठीक है. This is a person and this is a person, right. This one is A, this is one is A, B, right, and there is another person from another university. This is X, this is X, Y. So if I pick this person from this blue university and this person from this green university, So there's less probability that they will have many common friends. But if I pick this blue person and the other blue person from the blue university as well, so there is a good chance that both of them will be having more common friends. So same goes for the clustering in graphs as well, that the two nodes that belong to the same cluster have more common neighbors than two nodes that are not, if right. And another important observation here is that if a node is part of bigger cluster, right, if a node is part of a bigger cluster, its degree within cluster should be more than its degree when it's part of a smaller cluster, right. So I assume you know about graphs, but since the concept of degree has been mentioned here, so for example, this is a node, this is a node, this is a node, and this is a node, and let us connect them using edges. So this node is connected like this and this one, right. Okay, let me, for the sake of convenience, let me number them as well. This is node 1, this is node 2, rather let me give them alphabetical name. This is A, this is B, this is C, and this is D. Now the degree of A is the number of edges touching it. If you see, there are two edges touching it, so its degree is 2. Similarly, the node B is being touched by 3 edges, so its degree is 3. Node D is touched by 2 edges. I am using the word touch, otherwise the technical word is that there are 2 edges incident on node D. Similarly, at node C there is only one edge which is incident, so it means it has the node, it has the degree 1, right. So keeping this concept in view, now if we see this, if a node is part of a bigger cluster, its degree within the cluster should be more than its degree within when it is part of a smaller cluster. It means of course in the bigger cluster there is a probability that if the node is there, for example as compared to a node being in a smaller cluster, so here the probability of this node having higher degree is more, because there is a good chance that it will be connected to more people, right. Now to execute the density based clustering algorithm, we need to have a data structure which is the graph. Then this graph is basically stored in an adjacency matrix M, and adjacency matrix, if you don't know about it, let me draw it for you. For example, these are 3 nodes, and now let's say this is node number 1, this is node number 2, and this is node number 3. Now this adjacency matrix will be a 3 by 3 matrix, 1 2 3 1 2 3. Now here it's a matrix 2D array. Yeah. Now if you see, node number 1 is connected with 2. Now what I will do is that I will, in this cell 1 comma 2, I will place 1. Similarly, node number 2 is connected with node number 1, and node number 2 is also connected with node number 3. So in cell 2 comma 1 I will place 1, and in cell 2 comma 3 I will place 1. Similarly, node number 3 is connected with node number 2, so in cell 3 comma 2 I will be placing 1. The rest of the cells will get 0, right. So this is how the graph is stored in an adjacency matrix, right. Yes, if there could have been a possibility that these edges may have weights. For example, this edge has a weight, let's say 3.6, and this has 7.2, for example. In that case, 1 comma 2, this value would have been replaced by 3.6. Similarly, this one as well, because these both values represent. So this then when we have edges or weights on the edges, the graph is called the weighted graph, right? Okay. Now we will have a graph. G will have an adjacency matrix. The input to the graph, the density based clustering algorithm, will be the number of nodes in the graph, number of edges in the graph, and the density of the graph has this formula, which is number of edges multiplied by 2 divided by number of nodes into number of nodes minus 1. Okay, let me demonstrate it to you. For example, for this graph, let us compute the density of this graph. So if you see, there are 3 edges, 1, 2, 3. So in the numerator we'll have 3 into 2, yes, 6, divided by number of nodes. If you see, there are 3 nodes, so 3 multiplied by number of nodes minus 1, so this is 6 divided by 6, which is equal to 1, right? So the density of this graph is 1, which is 100%. As compared, for example, if we draw the same graph, right, with only one edge, right, in that case the density of the graph will be number of edges multiplied by 2, 1 multiplied by 2 divided by, we know now that this will be 6. So but and if you could see that the value using this graph, the density of the graph will be 0.33, right, which is less than the previously drawn graph. So this shows that the more the connectivity in the graph, higher will be the density, and the lesser the connectivity in the graph, the lower will be the density. So the density basically refers to or represents the connectivity in the graph, right? So in the density based clustering, we will be providing the algorithm with adjacency matrix. We will be providing a threshold density d dash, because for example, if you see here, here the threshold density was 0.6. So the algorithm extracted all the clusters having density greater than 0.6. So this will be required for the density based clustering as well. And then there is another density which is Cp dash. Its value also ranges between 0 and 1, but this is the required while making the clusters, right? So when we go to that particular step, I'll be explaining the utility of this this particular terminology, right? Now what happens is that we start we start with a single node as a cluster, right? Then we grow this cluster by adding nodes from its neighbors into that cluster, right? For example, we have these nodes, and they are connected, right? Everybody is connected with differently, right? And what we do is that we start with one node and we call, okay, this is cluster, then we grow the cluster by adding its neighbor. For example, this one is neighbor. Now these two red points become one cluster, then we grow further, then we grow further, right? This is how we will be growing the clusters. Then we continue to expand the clusters as long as following two conditions are satisfied. One, as we grow the cluster, the density of that cluster is greater than or equal to the threshold density. And secondly, there are nodes around that cluster, right? Maybe the density of the cluster is not up to the required mark, but the number of nodes around it finishes, so it means this is time to stop growing the clusters, right? So when the cluster has stopped growing, what we will do, we will remove it from the complete graph, right? And on the remaining graph we will execute the same procedure again, right? So this is how these clusters are extracted and identified, right? But this is a higher level explanation of the density based clustering. There are a lot of details to this algorithm which I think will need another lecture, so I will be explaining it in the next lecture. But for the sake of higher level understanding, you need to understand that it will start from single node and it will keep on growing, but again there are so many peculiarities in this that for example, if a node okay if a node has multiple neighbors, if a node has multiple neighbors, right? So how will we pick or choose one of them to be selected to be placed in the cluster, and how will we ignore the others, and then how are we going to select the first node? Like what will be the criteria? Will it be like the k-means, that it will be a random selection, or it is guided selection? So these are the peculiarities which are there in the density based clustering, which we shall be covering in the next lecture.